In this lesson, we discussed diffuse RayDepth. As we know, sample settings control the quality of our render, and we use it to remove noise from our different ray types. Ray depth settings control how far a ray can pass in our scene, how many times a ray can bounce in the scene. Now, as you can see in the ray depth section, we have diffuse specular transmission, volume, and transparency, and we will be discussing diffuse ray depth in this lesson. Diffuse ray depth controls the number of GI diffuse bounces, basically how much a light can bounce back and forth in the scene. We have this fairly complex interior scene that you can download from Arnold's support page. Also, for the lighting, I have an Arnold sky with a simple white color and a distant light that acts as the sun in the scene, and 3 portal lights behind those windows to guide the Arnold sky samples into the room and therefore having a render with less noise. We talk about lighting and different lights in the next section. At the moment, we have our diffuse sample set to 2 and our diffuse ray depth set to 1, and this is the render we get based on these settings. Now let me run the IPR and zero out the diffuse ray depths. By doing so, you can see immediately we are basically limiting our direct light rays to have any sort of secondary bounce. So that is why if you take a look at these areas where direct light can't reach, for example this wall, because they are not exposed to direct lighting and we limited our light rays to have any GI diffuse bounce by setting the diffuse ray depths to 0, they are black. As soon as I increase my diffuse ray depths to 1, we introduce GI diffuse bounce to our scene, and we are allowing our direct light rays to bounce one more time every time we increase our diffuse ray depth by 1 increment. And as you can see from the IPR, those dark walls and areas are now brighter. Let's open up the picture viewer and quickly compare this render with the previous one. In the first render, we have no GI diffuse bounce and we have those very dark areas. In the second render, we have 1 diffuse ray depth and we are allowing our direct light rays to bounce 1 time as they hit the first surface. So when the diffuse ray depth is more than 0, when a light ray hits a surface, it won't be killed off there. It bounces from that surface and illuminates another surface with smaller amount of energy and illumination when it hits it. That is why those previously dark areas are getting brighter. If I increase my diffuse ray depth to 2, we are gonna make those dark areas even brighter because we are letting our light rays to bounce more in the scene and travel between surfaces more. Now let's increase our diffuse ray depths to 2, and this is the render that we are gonna get. The scene compared to our previous render is brighter, and because we are allowing for more light bounces, the overall result is obviously physically more accurate, but increasing diffuse ray depths will result in a longer render time. Now let's increase our diffuse ray depth to 3 and see what is going to happen. So this is the render we are going to have from diffuse ray depths of 3. The scene is brighter compared to before and more accurate, but it's just an incremental improvement, and probably diffuse ray depth of 2 would be enough for this scene so we can also balance our render time. One thing I hope you noticed is the fact that even though we are increasing our GI diffuse ray depth, the noise is still there. Ray depth, as I mentioned, has nothing to do with quality and noise. If we want to get rid of the GI diffuse noise, we need to increase our diffuse samples. So let me, for the final render, increase my diffuse samples to about 7. You can see for interior scene, we might need to crank up the diffuse sample to get noise-free renders. And obviously the light portals that we have on our windows, and we discussed them in the lighting section, help a lot with the noise reduction in interior rendering. Let me set my camera samples to about 4 and diffuse ray depths, let's just set it to 2, and set the Arnold sky samples to about 4 as well, so we don't get any noise in the direct diffuse pass or in our direct lighting basically. And now we can take a look at the render with these settings, and this is the render. You can see it's obviously going to take longer because we have cranked up our setting to get a clean and noise-free render. And look at those small details and how clean and noise-free the render is. So in this lesson we covered diffuse ray depth, and in the next lesson we discuss specular ray depth. See you there.